So this video is to remind you how to work out upper and lower bounds, how to determine the limits of accuracy. And by doing so, you should be able to complete this set of exercises, 5 levels here, on the upper and lower bounds. But before you do, you should be really familiar with how to round numbers to decimal places or a certain number of significant figures. And there is a video all about rounding, which you can find at this URL here. Have a watch of that first if you're not confident with your rounding, but otherwise we'll begin. So let's say we're rounding to the nearest 10, and we've got an answer of 60. So can you see I've marked on this number line the multiples of 10 that are around about 60. Now if our answer has been rounded to 60, well, the smallest the accurate answer could have possibly been is halfway between the 50 and the 60, because anything to the left of that arrow would have been rounded down to 50, and of course anything at the arrow point 55 or to the right of it would have been rounded up to 60. And equally on the right hand side of 60, that's the sort of the break-off point between the numbers that would have been rounded to 60 or 70. So the highest possible number that could have been rounded down to 60 is just to the left of 65. Well, we'll say it's anything up to 65. We know that 65 itself would have been rounded to 70, but you've only got to get the minutest distance to the left of 65 and you'll be rounded down to 60. So, the 55 is called the lower bound and the 65 is the upper bound. And the way we can write this out is, let's say the number that we have measured is n. Well, we know that n, because it's been rounded to 60, must be somewhere between the lower bound and the upper bound. We know it's bigger than the lower bound, or it could be equal to the lower bound, of course, because that would have been rounded up to 60. But it's definitely less than the upper bound, 65. So we would write the range of values that n could possibly be as it's 55 or more, and it's anything up to 65, and that's how we write it out. So what about if we've rounded to the nearest whole number? So in my mind I think of the whole numbers around about 4, and I think, well, the lower bound must be halfway between 4 and the previous whole number, 3, so that's 3.5. The upper bound will be halfway between the 4 and the 5, which is 4.5. So now we've got our lower bound and upper bound, we can write our limits of accuracy just as before with the inequality signs. Now this time our answer has been rounded to 1 decimal place, and the answer that we've been given is 0.6. So what's the smallest that could have been? Well, it's halfway between 0.6 and the number below it that is given to 1 decimal place is 0.5, so it's halfway between those two. The upper bound is halfway between the 0.6 and the 0.7, so we write our answer down as a number between 0.55 and 0.65 with the less than or equal sign on the left. So we don't always need a number line, we can do it in our heads. Let's try the nearest multiple of 5. That's the answer we've been given, 75, but that's not accurate. That was a number that was rounded to the nearest multiple of 5. So let's think of the 5 times table around 75. There'll be a 70 in front of it and an 80 behind it, and just as before, the lower bound is going to be halfway between 70 and 75, and the upper bound is going to be halfway between 75 and 80. So we can write down our limits of accuracy like this. Another example, this has been rounded to the nearest multiple of 10. So can you imagine that 530 will be to the left, 550 will be to the right? We need to find the halfway marks between those points, and that should give us 535 on the left and 545 on the right. Now, as well as being rounded, numbers can be truncated. That means the unwanted decimal places are just chopped off, or the unwanted digits are chopped off from the end to make it a less accurate number, but more easy to deal with. So let's say a number has been truncated and the number we're given is 0.063. So there were places after the 3, but they have just been chopped off. So what's the smallest the number could have been? Well, I suppose there could have been nothing after the 3, and that would have been truncated to 0.063. Or I suppose after the 3 there could have been a 9999999 recurring. That's the highest it could have been. Well, the way we would write this one down is 0.063 on the left as the lower bound, and then the maximum value that can't quite be reached, but it is sort of the limit, is 0.064. And that's how we write down the answer for the limits of accuracy in this case. Now, as well as rounding to the nearest value, to the nearest multiple or to the nearest integer, we could also be asked to round up or down according to some situations. For example, if you're looking to find the number of 10-seater buses are required to transport 33 people, well, you will need to round to the nearest 10 because the buses come in lots of 10 seats. So if you rounded 33 to the nearest multiple of 10, you'd have got 30, which is 3 buses. And that's not enough to take all of the people. So in that case, you always have to round up. I know you'll have empty seats, but at least you'll be able to take all of the people. So here's an example of rounding up. And that word makes all the difference in this case. This time it's to the nearest multiple of 20. So a number has been rounded up and the answer is 12,340. So what's the smallest the original number could have been? Well, it could have been anything as low as 12,320. That's the multiple of 20 to the left of the number that we've got. It couldn't actually be that number because that number would have been left alone in the rounding process. So we put a less than sign before the n. And of course the biggest number is the number itself, 12,340, because anything slightly larger than that would have been rounded up to the next multiple of 20. So can you see the difference that the word up makes? Quite a big difference. Okay, so let's look at some real-life questions that involve finding one of the limits of accuracy. The sides of a square are measured to be 4 centimetres, and they have been measured to the nearest centimetre. What is the largest possible area the square could have been? Well, to find the area of a square, we multiply the side by itself, or we square the side, and we're looking for the largest possible area. So if the edge was measured as 4 centimetres, the actual value could have possibly been as large as 4.5 centimetres. So what we'll do is we'll multiply 4.5 by 4.5. And that should give us the largest possible area that the square could have, which is 20.25 square centimetres. A triangle has a base of 4.5 centimetres and a height of 9.6 centimetres. And these lengths have been rounded to 1 decimal place. So what's the smallest possible area of the triangle? So this time we'll take the lower bounds of the two measurements. We'll use the formula for the area of a triangle, a half base times height, and multiply those together. And that will give us a number with more decimal places than we need, so we'll round that to 3 significant figures, and that is the smallest possible area of the triangle. Okay, let's move on to algebra. A is 37, B is 61, and C is 99. They've all been given to the nearest integer. That means the nearest whole number. We want to find the largest possible value for A plus B minus C. Okay, well, let's think of the largest value for A. That would be 37.5. And the largest value for B is 61.5. But now we have to subtract C. So to get the largest answer, we actually want to subtract the smallest possible thing that we can. So this time we're going to find the lower bound of C, which is 98.5, and that's what we'll subtract. So to get the largest possible value for that calculation, we'll take an upper bound, add it to an upper bound, but subtract the lower bound. Can you see why? And that will give us the answer, in this case 0.5. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Transom website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transom subscriber.